So, hello everybody. Sorry for the slightly late start, and thanks to everyone for coming on. And hopefully, at least some of you registered for an account in advance, so you can actually get to try out some of the stuff that may or may not work if it's been a bit last minute, as often happens with these kind of things. So, what I'd like to start with is to ask everyone who has an account if they can try to log in, because getting logged in and sorted out can take a bit of time. And while that's happening in the background, I can say a bit more about what you're actually doing. So it's kind of do first and then find out what you've done. Such. And the instructions for the workshop are on GitHub. So it's the RSE Cambridge account. And inside that, there's an RSE Con 25 Dawn Workshop repository. So people who are following remotely, that would be a good place for you to go to start with. And if it's useful to see where you're going, that is the URL for the workshop. Out of interest, could you raise your hand if you do have an account for the session? Okay.
Oh, yeah. Do you mean an account generally or a new one set up specifically for this session?
The latter.
Oh, sorry.
Yeah, the accounts have all been set up specifically for this session with specific access to directories.
So everyone who registered should have had an email giving instructions for that. So while people are looking for that, so I'll just mention, so I'm an RSE at the University of Cambridge, where we host the superconductor Dawn, which is part of the UK's AI research resource. And today I'll show you that it's not that much different from other HPC systems. I know some people here haven't used HPC systems, but the introduction will be via Jupyter Notebooks to start with, plus some batch submissions. So hopefully everyone will get something out of it. And I'd say feel free to ask questions at any time. And there are also a few people from Cambridge here who are around to offer help and find my mistakes along the way. And so in particular, for getting set up and logged in, if you run into difficulties, any one of those will be able to help. So just say.
So just so you know, the email with the instructions has different numbers to put in the form than in this page. So it asked for 1 GPU in the email you sent us the other day.
Yes, so I was more generous that the number of nodes we got reserved was higher than I'd asked for, and so it means you can have 2 GPUs per person without any problem. If you have it in the running state, then you can launch the notebook. And the first bit, the workshop, what we want to do is download some examples and set up the environment for doing stuff. And to do that, from the Jupyter Notebook, what we actually want is a terminal window. So on the Jupyter Notebook page, if you click on File, New, then Terminal, that should bring up a terminal window for you. So if you have a terminal window, you've hopefully been able to clone this repository and to source the setup for this workshop. Okay. The next stage is the mid and batch job. And in some sense, these represent where we want to get to, in that they demonstrate multi-node processing with PyTorch and with PyTorch Lightning. But they're each going to request 2 nodes, and we don't have enough nodes for everyone to have them at the same time. There's going to be some queuing, but hopefully at least some of the jobs will complete before the workshop. They're very short jobs once they get them. So if you haven't already done so, then I'd encourage you now to submit your 2 batch jobs. At that point, I think it would be a good time to talk about what you've actually been doing so that you can actually understand a bit better what's going on. The first notebook is showing how to check the devices basically, and it runs fine on my home account, but the kind of sharing to other accounts, I think the permissions have got wrong somewhere, or the paths have gone wrong, so apologies. That the first one, I don't think it's going to run for anyone. You could try recreating the kernels, but I think to some people that might not mean anything, so I'm going to suggest that. But I would like to show you code and walk through what it would do if you're able to load it. And actually, there is a kind of secondary way you could do this. If you comment out the import lightning XPU import lightning and put the practical ML with PyTorch kernel, it will do most of it. So it will crash out on the bit that tries to use lightning, but you can actually see something quite interesting with the times it takes on GPU, different size matrices, and for CPU versus GPU. So Dawn itself is made up of 256 nodes. At present, there are challenges, should we say, with the power and the cooling for these nodes, and so they're not currently all running. So I think at present, maybe, I think today there are around 40 nodes running, and we've got 30 of them or so. And each node provides 2 CPUs with a total of 96 cores and 4 GPUs, each of which is made out of 2 components, which Intel sometimes calls stacks and sometimes calls tiles, yes. And the user can decide whether they want the GPU card to be presented as a single object or as 2 separate objects. And the reason for choosing to have one device would be that you get more memory, you get double the memory. And the reason for presenting as 2 devices is that you would hope to get twice the time for what you're doing. You get stuff running twice as quickly. Although I would certainly, I know there are people within the room who've been doing tests and they find that isn't always the case. So that was an interesting study, and we're still trying to find out why that is. So we've been in contact with Intel. They don't have any reply at present, but hopefully we can understand that a bit better. And the way you can choose whether you're looking at one device or 2 is by using an environment variable called ZE flat device hierarchy. If you choose flat, it means that you want to see as many devices as possible. So on a Dawn node, that would mean you'd see 8 GPU tiles. Or if you want to see only the 4 GPU cards as 4 devices, you'd set that to hierarchy and to composite, sorry. And so if anyone is adventurous and comments out the import lightning XPU, import lightning, and the cell that uses lightning, then puts the kernel to practical ML with PyTorch, then you can try what happens when you have flat, what happens when you have composite. Yes.
As I said, it's KH296 to do things, so we should be able to do marginal screen.
So something I mention in relation to the codes. So Dawn has GPUs that were produced by Intel, and the majority of GPUs in the world were not produced by Intel, they were produced by NVIDIA. And as an end user kind of working on the applications, you'd like to think you don't need to care. Unfortunately, at present, to some extent, you do. But there's some things that work better than others. And so the PyTorch family of AI applications is something where Intel has invested quite a lot. And a lot of the ecosystem around that, so PyTorch, Lightning with a bit of innovation, transformers, these are all the things that more or less do work. The way that they work isn't that different from an NVIDIA GPU as far as the end user is concerned. So in PyTorch, it's sort of made explicit that you have to choose what kind of device you're running on. And coupled with this, it means that each device you use has a different module associated with it. But one thing you can do so that ultimately you don't care whether you're running on Intel, NVIDIA, or indeed on a CPU, is that you can build this into your code. And there's an illustration in the first code block here that says you can give a list of device types in which you might be interested. There's CPU, there's CUDA, which is used for the NVIDIA GPUs. There's MPS, which is used for Apple GPUs. There's XPU, which is used for Intel GPUs. They've added a fictional device to show that you can put in some device that PyTorch doesn't know about, and it doesn't have to crash the system. So basically, you need to do two things. One, you need to check, can you load the module for that device? And you can protect against the case where you can't. And then if you do load the device module, then you can ask PyTorch, is this device available? And it will check and see if it knows it's there. And after that, when you actually run some code, you'll say that the data should go to the GPU device, model should go to that device, and then everything will work transparently depending on which device you are. So that's not entirely satisfactory from the user point of view, in that they have to kind of specifically choose the device they are to some extent. And other people thought that this is ideal. So there's another module, PyTorch Lightning, which is set up so that it should select whatever device you have available on your machine and make use of that. And if you use the official version of Lightning, then it doesn't actually know about Intel GPUs. It does know various types and will choose them automatically, but it doesn't know Intel. And various people over the years have tried to solve this problem. And there's at least one other in the audience, I know who has done it. And I have too. And so the module that got downloaded, or didn't get imported here is Lightning XPU. And that makes it so that Lightning understands about Intel GPUs. And that, once it's working, it's really nice, and that you can generally take exactly the same code, try and take it from one machine to another. So I can test code on my MacBook, which has an MPS GPU, transfer it to Dawn, and it will run. So, and presumably also on a NVIDIA. Okay, so did anyone have a go at actually running stuff in the jet devices?
Everything that doesn't require lightning import.
You guys okay?
So what did you find in terms of the time? So what it's doing is it's multiplying two square matrices.
Yes. That was the easy
And
part.
they're getting bigger as you go along. And it makes multiple attempts for each size. So did you have any, and it should have printed out the time it takes for each attempt in the last cell. So first of all, how many devices is it showing that you have? 4. Okay. So that's because you've run with the steady flat device hierarchy equals that. If you were to change that to composite, you should see that you have 2 devices showing up.
To restart the kernel as well. I have to restart the
You
kernel.
have to restart, yes. Yeah. Once Torch has convinced itself you have 4, they've got to convince otherwise. So does anyone have any observations on the time, how it varies as you increase the matrix size? Or as you increase the number of attempts?
Sorry, I've just done the reset to try less interesting composite results, so.
Sorry, which kernel do we use to actually run anything? Because
To actually run anything, you need the practical ML with Python.
right, and then import Lightning.
You need to comment out the imports of Lightning and Lightning XPU and the cell that tries to use them.
Thank you. Yeah, that worked now. Thank you.
You can try just having a fictional device.
It's the fastest device there is.
What these are.
If I comment those out, then I can't run this line. But if you run that, and then
How long did it take to run?
Seconds.
yeah, it's not too long.
Mine just goes.
It's like
Change the kernel. You see you're on no kernel. Cool. And then try it all again. Yeah,
Yeah, okay, well, yeah. And
that one.
let's get rid of this. Well,
Skip it. And then the last one should work.
So, does anyone have any comments on the time? Did it behave as you expected, or maybe? Don't know.
What I'd quite like to do is write the results out and then compare them.
Yeah.
And you have to reset and the kernel.
Open another window.
What's that? Ah, okay. I should realize it. I would normally do this all. I tried to actually plug into the terminal, but it wouldn't like through a terminal locally. Because I figured that would be an easier way to go back and forth between these. You can't.
you write it out with the file.
Yeah, Jupyter Notebook not really terminal friendly. This gentleman has done what I wished to do.
so this is with it in flat.
Oh yeah,
Very slow.
Mine was very slow. Interesting.
Are you going to
That bit with
swap it?
there'd be something wrong.
that flat and that composite. So that's 4 devices. That's 2 devices. These numbers are bigger.
Good enough having problem. Yeah, that's the opposite of what I
Can
was.
you divide the flat by 2?
There's like an extra 3 digits there, so it's like for the first one.
What are you trying to do?
I'm just wondering, like,
Yeah, is it proportional? Yeah, because it's
Don't use it.
out by
The practical ML one.
like 3. Yeah. It was, yeah, you like Spinx PU3 was incredibly slow.
If you, this, so you,
Access. And then
yeah, so that's with
actually,
so because In this one, it's when we're treating each physical device as two separate things. They've only got half the total memory capacity,
Right, okay.
and whatever problem type this is just a little bit too big for that, or very much too big for that. So it can't run the 65k example.
So in addition to the check devices notebook, there are also some examples from a course that was actually prepared by the Institute for Computing Climate Science, and that is where the kernel practical ML with PyTorch has actually come from. And so if you want to try those at some point, so those are actually useful also for people who don't have any previous experience with PyTorch and are interested in learning how it works. And on the course repository, there are both exercises which you can work through step by step and follow instructions and solve problems yourself. And then there are work solutions, which are the ones that I've directed to here, and which you should see in your kind of browser window. There should be a folder, practical PR with PyTorch, and inside that there's a work solutions folder which has 4 notebooks. 2 of them only use CPUs, while the others show how you can set things up so that if you have any kind of GPU, then you'll use that. Otherwise, you'll fall back and run on a CPU. And there, as you may have seen in the check devices, you get, as you'd hope, a much faster processing with the GPUs. So I think if you try exercise 4 on CPUs, then you get kind of like minutes per training epoch, while if you use on GPUs, it goes down to seconds. So given that, actually, I mean, if anyone wants to try those, yes.
Basically adding to the print statements right into the file.
Well, no, I just copy and pasted it out.
Okay, yeah, that is, all right, I'm not gonna go down this whole log file modification.
Helping out on the edge.
Time that we're getting. Time.
So it's the elapsed time from time to time, which is
Doing the
Seems very.
So someone has pointed out that if you look at the speed on the GPUs, the first attempt at the multiplication is order of magnitude slower than subsequent attempts. I think by 3rd or 4th attempt, it's more or less constant. So does anyone have any insights as to why that might be?
Do you have them in the fixed power state or not?
So Chris might know that one.
Something who's going to talk. Do we have which of the fixed power
The devices.
We haven't capped.
Yeah.
Yeah. So they'll go lower, but they won't go
Yeah,
higher.
so some of it could be clocking up, or it could be jet caching, depending on what Intel does.
Again, that's something that I've tried asking Intel, and they said they'll get back to us.
Is it slower after a couple of like? It makes sense to be slower on the first one ever, right? Why is it then slower in the second? Okay.
Yeah, I would suggest probably power then, rather than feeling.
Right.
Yeah. So kind of, I think the answer to why it's like that is that we don't exactly know. But one thing that's going to have an effect is that stuff is being pushed into the GPU memory. And so that would explain why the first one is slower. But as people point out here, why the second one is slower. Maybe there's some caching still continuing, I don't know. Maybe there's some power adjustment going on. But in detail, I don't have an answer to that. So there's some caching stuff going to memory, which makes it more accessible on the GPU than before it does anything. And that, I think, is kind of order of magnitude change seen at the beginning. And then some other stuff that I don't have a good explanation of.
So the GPU memory is slower than things going to CPU. Or not expected.
Sort of, in that stuff is kind of more, I guess there's more better availability in the CPU memory. So what are you saying?
Well, just on the numbers for the CPU, so they never go as high as the memory load times for the GPU, for me at least.
I mean, also, I mean, it's not just the data numbers are relevant, but I guess the bits and pieces related to the code that's being run. So there's a big change when you change the matrix size. If you notice that.
Yeah.
Well, with the CPU, it kind of scales up gradually. So if you start with a 1-by-1 matrix, it's surprisingly slow. And I think it gets faster for a while and then it slows down again.
Yeah, but with the GPU, mine on certain orders it just drops right down to very small times as well.
Yeah. Yeah, it does. I mean, I don't know why, and it's something that maybe one day Intel will tell us because they're always confident. And I remember with the GPU, it kind of is more or less constant for a while, then it starts getting a lot higher when it's close to the memory limitations. And if you looked at the difference between flat and composite, you'd have seen that the highest matrix that gets multiplied is double the size with the composite one. And I seem to remember there's a definite slowing down as it gets close to the limit, which I can imagine it's kind of a bit like working with swap space and arranging stuff around. Did anyone try any of the machine learning with PyTorch examples? Okay. Maybe you can have a go at running the third notebook from the work solutions for practical ML with PyTorch. So that one is one of the kind of typical machine learning exercises where it's classifying numbers and trying to identify which one. I think it will take about 5 minutes to run for the number of epochs it's given as default.
It's 500 digits.
Right.
This one.
I understand what
Same code.
you're going for, right? It's different to what you got. I'm just looking at the last one, assuming that everything's kind of like leveled out.
Yeah.
And it's only running on one device at a time, like one GPU.
So each line, one device.
Yeah, so that is flat. So it's quicker, but it's actually not significant. Is that what you got? What you got like 10 times?
Oh no, so that was the 10 times one was also the J as well. It's fine. So yeah, it's no,
And then like maybe if I look at like 32, maybe 32, like 83.
mine was 104 to 115. So
Maybe a bit of variation.
good variance. I mean, the RNG to visualize things unseeded, but that shouldn't really matter for a MATLAB.
Very nice time where it's not one at all.
Yeah, mine is like generally. 10%,
Yeah, it's
I'd say.
probably less.
Like obviously that's like per device.
Yeah, so you would get more free, but I assume these are running concurrently.
How many? Guess mine failed in the attempt to scale up back to flat.
So you failed one.
And then I reran it to go to flat, but I'm still only getting the number of,
So you
You have
restart.
to
yeah,
restart.
no, I thought I'd done that.
Have you got two open? I think you can't have two open and running at the same time.
Too convenient, wouldn't it?
As in, like I opened two, but one of them is dead.
So I tried to create two separate files. This is the flat file. This is thinking that would be enough. No.
Okay, so let's come up that. And go to the next bit.
I've also been trying to see if I can solve that import issue with Lightning, but
Can I ask, recent PyTorch, have they updated something so you no longer need IPEX, or is that not right?
They have.
They have.
So anyone who's already used PyTorch will know that for quite a while to use anyone who's used PyTorch on Intel machines will know that to use PyTorch, you need to import a special extension. And as of the last version, which is 2.8, that's for the stuff I've tried, it's not necessary. So you can now do without it. Intel tell me that there are still a few things where you might need it. They mentioned they weren't sure, maybe VLLMs, so there's some stuff possibly. But in general, I mean, I think it's a big improvement. One, you don't need a different extension to be added. And two, if you look at the multi-node processing, you now don't care about the Intel extension for that either. It's all built into the PyTorch module. Which brings us to the batch job. So has anyone had their batch jobs finished successfully or unsuccessfully?
Yeah, so I assume they're unsuccessful.
as in the ones now.
Yes, the one you submitted at the beginning.
Sorry, I have submitted a job using the newer version of report, but that's not quite what we're talking about now.
My Lightning one ran. My DDP did not.
So at what point did it fail?
Let me read all.
So I've also seen occasional random failures and I'm not completely sure why. I suspect if you were to submit it again, it would probably run.
My downloads failed during it.
Yeah, so I
DDP one.
manually went in and downloaded,
Lightning one.
but now I get a different error. So maybe I did that wrong.
Oh, you mean as in just the stuff we set running ages ago?
Yes.
Oh, sorry. I was like, oh, it's another thing. I think
Yeah.
Lightning ran fine, but the DDP one was missing some data.
So mine says unknown option PPN, my MPI exec command. And I'm not going to open it again because I can't press escape on it. I'm gonna click it.
I am still running one of them.
Recently.
It's the time on that. It's 43 minutes.
In the top, it runs which MPI exec, where is that coming from?
Sorry,
When you said
yeah, it might be that. So I'm maybe now be in the wrong environment.
So
the MPI exec.slurm is not the one it should be using.
Source the what thing again?
Yeah.
So from the sound of it, at least 2 people have had their lightning jobs run successfully. And 3 people.
Yeah, I've had the lightning job run. How do you know?
Okay,
Like,
so-
print it out.
So you
Lightning, yeah.
They could just do an element.
Lightning dot box. Yeah.
Just trying to try out.
Sorry, I got myself distracted. Yeah, I have had something.
So in
successfully
do lightning dot
and this is the code for that. And if you have a look, it doesn't say anywhere in it what device it's using. So by default, if Lightning has access to more than one device, then it will try and use all of them. And so that's what it's done here. It's used all of the 16
you can press
that we've been available on the 2 nodes.
yeah.
And you can, if you want, change what it does. So you can say, okay, I'm just testing. I don't care how that runs on all the devices I could use. And you could change in here. It says train equals L.trainer max epochs equals 1. You can add in there a parameter strategy. You can put that equal to a single device. It will just run on one device. And another thing you can do is you can set it up as FDSP, which is FSDP, fully sharded data parallel, which means as well as splitting up the data between nodes, it will split up the model parameters between nodes. And that's something that can be useful if you are running out of memory, even when you're using the composite. And so for this example, I mean, you could do it, it would run. Would you expect it to be faster or slower than distributing the data?
Sorry, ask that question again.
So with PyTorch, which has been used in the background here, you can choose to distribute the data between GPUs and have the same model on each GPU, meaning all of the model parameters, or you can split up the data between GPUs and also split up the model so that only some of the parameters on each GPU.
My guess would be the latter by intention, but
It would be faster or slower.
I would hope it's faster. The latter.
I think it would be slower.
Why would you think it was slower?
Because I think there's more communication going on.
So you're right, it's like the communication happens over. That wouldn't necessarily be true of all devices, because I know
He's right.
I know that people in the audience have kind of looked at this, though, how fast is the communication between kind of GPUs and between other things, between nodes and between GPUs.
And presumably also how fast is the communication, whether you're flat or composite, right?
Yeah. Because that's kind of internal communication within the GPU, there is communication across GPUs, which would or could not be fast.
What's printed in the
It's good.
what's printed in the logs for the DDP?
So in the DDP, it will.
Tell you what my log looks like. There's an error in downloading the file.
I got that the first time and then reran it.
You just reran it and it was fine? I was gonna change it so that it actually had download equals true. If that makes sense. But it just worked for you without having to make that modification.
Yeah. Moment saw the error message, and so I just ran it again without
All right.
So what other information did it give you?
nothing. It's just yes.
Yeah. So I think it should tell you also the accuracy after each epoch.
Yeah, yes, you're right. There's a line at the bottom. Average loss accuracy.
Oh yeah, I cut mine before it got to the end. That's okay.
Okay, so hopefully you've been able to see that running code on different types of GPU, whether it's Intel or something else, it's not that different. Once you get past the installation problems, which is basically what brought us down, was the not being able to load the AI kernel. And hopefully you've been able to see that if your batch jobs run, then you can distribute data between different GPUs. And on the user side, you don't do that much. Especially if you use Lightning, so it will just, you don't do anything. I mean, you just say run and it will find the GPUs and use them. And I think some people are already using Dawn. I hope others will apply to use Dawn. And the way to do that at present is basically now UKRI has put out two calls. So one focused more at academia and another focused more at, and you can submit a request to them saying, I would like to use an AI supercomputer to do some work. And so Dawn is one of them. There's another, actually much bigger in Bristol, and that's using NVIDIA GPUs. So you might kind of say, oh, I want to use the NVIDIA GPUs, and by all means apply there as well. But you could find out at some point that even if they have more resources there, they're full up. And so having the flexibility to switch between different centers, different GPUs, I think would be really useful. And for the audience we have here, I'd also say that I think RSEs can make a really valuable contribution to the AI work and making different systems useful to as many people as possible. And so we've had, I mean, we kind of mentioned them in passing, but the people at the Turing Institute have been looking at running on different systems, and they've been comparing a system in Birmingham with Dawn, and that gave some really useful advice and some information about things that weren't working as well as we'd like them to. And in the longer term, we'll hopefully improve on that. And I mean, I mean, I think it's really important for advancing the systems that RSEs are getting involved. So if you're working with people in your research groups within your university or within your industry, if you're in industry, who are doing AI type stuff and could use some large amounts of resources, I'd really encourage you to get involved. And you build up your skill set, you help them, you help us. So it's win-win for everyone, I hope. Okay, so I think I've covered pretty much everything I was hoping for in the workshop. I'd like to invite anyone who has any questions, please do ask.
So just for the access call, so there was the previous expressions of interest, was it?
Yeah.
For people who submit those and then didn't hear back, do they just need to fill in the new forms?
Yes.
I thought that was the case, but we had someone asking us, so.
Yeah, I mean, if they didn't hear back, I think that's very poor.
It would have been nice if they were told, oh, please apply again.
That's not down to our service provider, that's a decent.
That's what we thought.
Yeah, it used to be that with the expressions of interest, the people got invited then to apply for resources, which is a bit odd. Why not do it straight away? And UKRI decide, do some filtering, then send to Cambridge and Bristol the applications that they wanted to be considered and ask for technical feedback. We gave technical feedback and said sometimes this will run well on Dawn, this could have problems. The suggestions and comments were completely ignored. UKRI just went ahead anyway. Now they don't even send us the application, so it's all decided by UKRI and they will assign or not assign. And I'm sure will be good decisions. Okay, so if there are no more questions, then thank you again everyone for coming. And I can give you about 1 minute of your life that you weren't counting on having.